Hey guys, good morning. This is the video for Stats, Chapter 10, Test Corrections. I listed before the names of the people that if they did the assignment in full, that they would, that it would have an effect of a letter grade change to their grades last grading period. So this is only for last grading period in the class stats. Okay. That being said, it is optional. It is all or nothing. You're either going to take all the notes and turn those into me, or you're not. I'm not going to take, if it doesn't look like you've done the full assignment, I'm not going to take it. There is no exception to the due date, so it is due midnight Thursday because it's a totally optional assignment. I've already given the test. I've got no requirement to take any excuses as far as, you weren't able to take advantage of this option. Also, no cheating. I will triple check to verify that it is your handwriting. I do have quite a lot of samples of your own handwriting here at my house. So the list of names that I put on the last video, those students, I can verify that it is your handwriting. So no having a friend, no copying a friend, no making your little brother do it for you. It's got to be you. Okay. So let's get to it. Question 1. So question 1, it says, the government claims that students earn a mean of 4,500 during the spring break from studies. A random sample of students gave a sample average of 39.75, and a 95% confidence interval was found to be between 35.25 and 44.25. Which of the following is a correct interpretation of the 95% confidence? So all this subject was not really necessary, so to speak, because you're really just saying, what does it mean when you perform a confidence interval? So if we look at this, we actually did this activity in class. So question number 1. If you take a random sample, let's say you take a simple random sample of 100 students. Okay, hopefully you can picture these 100 students here. Okay, so let's say there's a list of five rows and 20 here. And you can imagine each of these numbers. And so like $3,700, maybe your friend makes $4,500, maybe you make $10,000, who knows? Maybe somebody else just makes 1,000. Imagine some possible numbers are populating this table of 100, and that this was a random sample of 100 students. Okay, now what are we thinking about? What we're really talking about is what is the average of all these numbers. So adding up all these numbers and then dividing, add them all up, that's the summation symbol, and then dividing it by 100, and that's what is the average of just this sample. All right. Now again, my population is super big. I don't even know how big, but let's think about my population, and then it's talking about all students. So this could be 10 million. So again, from this 10 million population, a simple random sample of 100 were selected from here. So each time I select this set of 100, all the numbers are going to be jumbled. And so if I do this many, many, many times, if I take a sample of 100 from this population and then populate a table, and then take the average, and then I do it again, and then I do it again, and then I do it again, notice it would be shocking if all of these were the same, because they're actually very random. It's just based on chance variation that each of these average samples would be, it would be shocking if they were exactly the same, because they're not pulling from the same numbers. They're pulling from the same population though. So if I pull from these 10 million and make a simple random sample of 100, they're saying they did one sample and they got the average of their sample to be 3,975. And then they actually did a confidence interval, which gave them the variation of between these numbers. Now, what does that mean? This is the actual true population mean. Right? I'm trying to approximate the true population mean. I know the exact mean of these 100 kids. That's just my sample. But I'm trying to use this single sample average to make an approximation about this full population mean, and that's that symbol mu. And so we're basically saying, I'm thinking that the truth is somewhere in here. I don't know what the truth is. In fact, I'd be shocked if I got exactly the truth, because I only talked to 100 people out of 10 million, okay? This is the essence of what a sampling distribution is and what a confidence interval is. Okay, so what's the right answer here? If we repeat pulling of many, many iterations of 100, if we repeat many, many samples of 100, let's say we do 100, we're actually saying that about 95% of those confidence intervals will capture, or will, this question said the word contain. I usually use the word capture. Will contain the true earnings of students. And you're thinking, well, the true what? The true mean or the true average, right? But not the sample average. I mean the population average. And that's really what I want to know. I want to know, what does the average student make? But I don't want to have to talk to every single student. I want to only talk to 100 students and see if that number would be relatively accurate in approximating that number. That's in essence what we're doing. Okay, so that's question number 1. That took a while, but it's going to help us tee into the other questions. So let's look at the second question. The report of a sample survey of 1,014 adults, they said with 95% confidence between 9% and 15% of all Americans expect to spend more money on gifts this year than last. What does that mean? That means the method used to get the interval, when used over and over, will produce intervals that will include means capture, that will capture 95% of the time, about 95% of the time. So in English, what they've done is they provided 2 ways to essentially say the same thing. And each of these other options are saying slightly different things. So you have to understand the process to know which one is making sense. You can't just memorize the words themselves. All right. Now, let's take a look. So what should you write for question 2? I would say let's write this method used many times instead of the word capture or contain includes the true population percent about 95% of the time. So that's another way to say the same thing. And what's different here is instead of the true mean, is the true population proportion or percentage. So you can ask a yes or no question and do a confidence interval, or you can do a measurement. This was a measurement question. So this is quantitative and that's categorical. And you can do both for each. All right, question number 3. Quite a lot of people are starting to get this question right. We've struggled to get this one right the last few chapters. So it states, A 95% confidence interval for the mean reading achievement score for a population of a third grade student is between 44.2 and 54.2. Suppose you computed a 95% confidence interval. What would happen? Okay, so if a confidence interval is this, we can actually show this in a couple different ways. All right, so you might be thinking, well, what does that mean? Well, if I subtract the 2, and then, type that in wrong. And then they're only apart by 10 and divide that in half by 5, then I know 44.2 plus 5, that the number in the middle here is 49.2. So this is 49.2 plus or minus 5. So what happened here? Well, when they took the sample, they're not showing all their work, but when they took the sample, they got a sample mean of this and a margin of error of 5. So, and they did that at a 95% level. So what would happen if instead you did it at an 89% level? There's really nothing different in the formula. The margin of error calculation would be your Z star or T star times the standard error. Well, what is the standard error? Well, it's, again, this is your margin of error. Your standard error is your standard deviation of your sample, or sigma if you have it, over the square root of n. All right, so assuming whatever this is and whatever this is the same, whether you do a 95 or a 99, then this number doesn't change. So let's say that this is the number 3 and you took a sample of 100. Okay, so if you did a 95% confidence interval, the T star would be 95, 1.960. 1.960, and this would be the number 3 divided by the number 10, because I took the square root of 100. All right, so this would be our margin of error. Now it's going to be off. It's not going to be 5 because I changed these numbers, but so if we get this number, whatever it is, and we're saying, let's say I make this s of x, I leave that a variable. We know that the margin of error is 5 when we do a 95% confidence interval. Well, how would it change if we did a 99? If we did a 99, instead of multiplying by 1.960, we're going to multiply by 2.576. So let's think about what happens here. 2.576 times the same standard deviation, divide by 10 again. Notice how this is going to be a bigger number, right? I'm multiplying whatever number it is by a bigger number. So the number is going to increase. So what does that tell me? It tells me that the interval will be wider. It'll be wider because the margin of error will be bigger than the number 5. So conceivably, this will be the same, but this will be bigger. So it'll be plus or minus 9, let's say. It will be bigger. So instead of the interval being 49.2 plus or minus 2, it will be plus or minus 9. So it'll be 40.2 and so 58.2. Notice that this is significantly wider on a number line than that. Check out the next video for the next group of questions.